Okay, 17.1a notes, part 3. I hope this is going to take care of the rest of this problem. On page 1, the first video, we just did problems where we had to find one missing side, one missing angle. Now we're going to deal with problems where we have to solve the whole triangle, find every part that they didn't already give us. We're going to draw ourselves a right triangle. Don't care exactly how perfect it is. There we go. Make a right angle in one corner, call that C. Unless somebody tells you otherwise, we're always going to assume that our right angle is C. So we're going to go straight up, call that one the 90-degree angle. And straight across from the capital C should be a side labeled lowercase c. Doesn't matter which of these other two angles we call A, which one we call B. I'll just call the top one A. The side opposite from A is lowercase a. I'll call this angle here B. The side opposite from angle B would be lowercase b. And then we'll look and see what kind of information we have about some of these other things. I know that side A is 7, so I'm going to put a 7 down here. I know that side C is 15, so I'm going to put a 15 right here. I know that my angle, my 90-degree angle, is at the C. We labeled that. But nobody told us any of these other angles. So we're going to have to deal with finding an angle. And we're going to have to find a missing side. So if we look over here, we see that Pythagorean theorem, which I know you've been doing Pythagorean theorem since middle school. I think in middle school we always did it with decimal approximations. Mostly probably in IM2 we also did decimal approximations. Sometimes today they're going to ask us for a decimal approximation, nearest tenth, nearest hundredth. Sometimes they're going to ask for an exact value. An exact value means we need to know about simplifying radicals. If you don't remember how to simplify radicals, there's an optional 17.1a video that you should go look at. So let me see. Let's find the missing side first, because Pythagorean theorem is a thing that's easy to most of us. So Pythagorean theorem says a squared plus b squared equals c squared. In this case, my a was 7. I don't know my b. And my c was 15. Okay. So 7 squared, 49. Use your calculator if you need to. But b squared is 225. I need the b squared by itself, so I will subtract 49 on both sides, which gives me b squared equals 176. Okay. And to get rid of the 2 exponent, of course, I will take the square root. There are certain cases where we'd throw a plus minus in front of that. And technically, we probably should. But can the length of a side of a triangle ever be negative? We'd end up throwing out the negative anyway, so I'm not worried about it. If we wanted to split this up and get an exact answer, I would say 176. It's divisible by 16 and 11. Yeah, I used a calculator. And then 16 splits up to 4 and 4. And usually we keep on continuing down until we get to primes before we start matching. But I happen to see matching numbers right now. So instead of going forever until I find matching numbers, until I find primes to get my matching numbers, I'm going to say pair of 4s, that's a 4. And then I have this 11 that can't split up, it's prime. So square root of 11. So I have b equals 4 square root of 11. If, however, they asked you to deal with this in decimals, my calculator tells me 13.266, and it doesn't matter whether I enter that as the square root of 176 or the square, or 4 times the square root of 11, I get that same result. That's one way of checking to make sure that you actually simplified right, is checking whether you get the same decimal both ways. Our homework either asks for exact answer or nearest tenth. Nearest tenth means one place after the decimal. But I also have to look at the number that follows that to make up my mind about rounding up or staying the same. 13.2, and when that 2 is followed by 5 or anything larger than 5, it goes up from there. In this problem, they didn't tell me inches, feet, meters, miles. I'm just going to leave it that way. I just circled 2 answers. And some of you keep doing that on your homework. Don't circle 2 answers unless they ask for it 2 different ways. Decide what they asked for and circle the one that really fits what they asked for. Whichever one they actually asked for, that's what's going to go over in the answer space. Mostly the problems that are like this in our assignment are asking for nearest tenth, so I'll put that over there for side B. And then I could find angle A or angle B next. I think I'm going to find the measure of angle A. I'm going to look back to my picture and say, what do I know? I know the side I just found, but I'm not going to put it on my triangle because if I can possibly figure out the rest of this without using the rounded off number, I'm going to do that. So if I want to find angle A, here's angle A, and I want to look at the 2 numbers I know. I do know my hypotenuse is 15, and I know this other side here, which is not touching angle A, it's opposite from angle A, and it's 7. So we're going to call this one my opposite side. The one trig ratio we know that uses opposite and hypotenuse is sine. And so the sine of an angle is always equal to the opposite over the hypotenuse. If you're looking at your SohCahToa, that's that part right there. Okay. On page 1, in the last video, page 1 of the notes, we kept saying, take the sine of the only angle you know, because we don't know any of the angles. So how about the sine of the angle I want to know equals the side opposite from that, which is 7, over the hypotenuse, which is 15. I can't just divide out the word sine. That's not going to work. The only way to get the A out of the sine, the only way to find the measure of an angle is to do inverse sine of that fraction. Notice I did not change it into a decimal and round it off first. I'm trying hard not to round anything off until I get to the end of the problem. Then I can put it in my calculator. Most calculators, that's a second or a shift button, then your sine button, and my calculator gives me 27.8. That was actually 27.81813, but as long as the digit that followed the 8 wasn't 5 or larger, 27.8 is good. Then I need to find the measure of angle B. And I'm going to show you 2 different ways to find the measurement of angle B. Okay. I tried to do this without using any numbers that we worked out ourselves, using only numbers that were given to us. If I wanted to do that, I would look at angle B, and now that I'm looking at angle B, I have to say 7 is no longer opposite. 7 is touching angle B, so I'm going to call 7 my adjacent angle. Using adjacent and hypotenuse, we're going to have to use cosine. So I'm going to say cosine of the angle I want to know equals the adjacent side over the hypotenuse. And again, I want to get B out of my cosine, so I'm going to say inverse cosine of 7 over 15 equals B. And my calculator gives me 62.2 degrees. Okay, let me go put some of these things over in the answer space. I just got angle B, 62.2 degrees. I got angle A is 27.8 degrees. Don't forget to put the degrees on these answers. If you do a quick add with your calculator, you'll notice that 90, 62.2, 27.8 add up to 180 degrees. But we kind of knew that, didn't we? The angles of a triangle always add up to 180 degrees. So even though I like to avoid using numbers we created ourselves, sometimes we just take a shortcut and we say 180 degrees for the whole triangle, minus the 90 degrees we know, minus the 27.8 degrees we know, and we get 62.2 degrees. And even though that's not as accurate, because if you messed up angle A, you're going to mess up angle B too, I almost always take that shortcut, and I recommend taking that shortcut. Okay, so here's all that stuff typed in case you want to look at it again a little bit more detail. Pause if you need to look. Okay, last example. Solve the triangle again, so I have to find everything. I already wrote in that I know angle B, I know the 90-degree angle at C, I know side A. Remember that if this is angle A, this is opposite from it, so this is side A. Okay. I'm going to worry about the angles last. I'm going to worry about the sides first. Can't do Pythagorean theorem first this time because I only know one side. The angle that I know is angle B. When I know angle B, I'm going to be working from angle B. This 8 touches angle B, so we're going to call this the adjacent side. And opposite from the right angle, we're going to call this our hypotenuse. Using adjacent and hypotenuse, I'm going to have to go with cosine. So I'm going to say the cosine of the angle I know, which is 54, equals the side adjacent, which is 8, over the hypotenuse I don't know, and we're going to call that hypotenuse C because it's opposite from lowercase c. Okay. Just like we did on page 1, we're going to put a 1 underneath this. We're going to cross multiply. This puts here and here. So we're talking about C times cosine 54 equals 1 times 8 is 8. And I need to get my C by itself, so I'm going to divide by cosine 54, divide by cosine 54. I hate it when this fraction bar doesn't go all the way over, so let's make sure we do that. That gets the cosine 54 canceled out, and we get C equals 13.610, a whole lot of things out there. If we want it rounded to the nearest tenth, which is what most of our assignment asks for, that C equals 13.6 is the place I need. 1 is not bigger than 5, so it doesn't push it up. 13.6. I don't know inches, feet, meters, miles. I'm going to put it over here for side C, 13.6. I knew side A in the beginning. I didn't write it down. Let's make that work. Side A. We need another side. Now that we have two sides, if we kept it totally accurate, we could use Pythagorean theorem, but I'm not going to use Pythagorean theorem because I don't want to use any rounded off numbers here, and it's too hard to keep that totally accurate. So I'm going to look next at the other side that I don't know, which is B. And B is opposite to the only angle I know. So the one that uses opposite and adjacent is tangent. So I'm going to say tangent of the only angle I know is the side opposite, which is B, over the side adjacent, which is 8. And again, let's throw 1 underneath. Let's cross multiply. This is 8 times tangent 54 equals B. This time, B's by itself. I don't have to do any division. I'm going to go straight ahead and put that into my calculator, and it tells me 11.011 equals my B. Rounded to the nearest tenth, I get 11.0. And you could write technically just plain 11, but I like to write 11.0 because it tells me that it's accurate to the one place past the decimal, even though it looks like it's a whole number. 11.0. Okay, one more thing to do. I haven't found that missing angle yet. I'm going to do that little shortcut that I did on the last problem, and I'm going to say all the angles of a triangle have to add up to 180. So if I take 180 minus the 90 I know, minus the 54 I know, I'm going to end up with the last angle, 36 degrees, and that is angle A. Don't forget to put your degree symbol when you do this. Last problem, and let me go to the next page. There it is, typed up for you. If you need to look at it in more detail, if my writing's too sloppy, still adjusting to the new stylus. A little better since I got a finer stylus. And that should be all for 17.1a. If you have questions on 17.1a,